Despite its proximity to us, the Earth's core remains a mysterious structure. We can categorize it into two parts, the inner core and the outer core. Additionally, it is predominantly composed of iron and is responsible for generating the Earth's magnetic field. Let's now examine its functions and structure more closely. The outer core. The Earth's structure can be likened to that of an onion, consisting of 4 layers, each with a distinct composition and role in the planet's geology. 2 of these layers form the core. The outer core is situated approximately 3,000 kilometers beneath the surface, and is the only liquid layer of the Earth due to insufficient pressure to maintain a solid state. It primarily consists of iron and nickel with traces of sulfur and oxygen. Furthermore, the temperature inside the outer core reaches exceptionally high levels, up to 6,000 degrees Celsius, 10,832 degrees Fahrenheit. As a result of the convection of fluid ferromagnetic substances, the Earth generates a magnetic field, which contributes to a stable atmosphere and favorable conditions for life. The inner core. The innermost layers of the Earth comprise the inner core, likely a solid sphere with a radius of around 1,200 kilometers, equivalent to 70% of the Moon's radius. It possesses a scorching temperature similar to the surface of the Sun, approximately 5,600 degrees Celsius. Similar to the outer core, the inner core consists mainly of iron and nickel. Notably, a 2015 study suggested the presence of 2 layers within the inner core. The collected data indicated that the crystals in the inner layer align in an east to west direction, while those in the outer layer align from north to south. This implies a phenomenon that caused the core's orientation to flip, resulting in the crystals in the outer inner core. However, further research is required to confirm this hypothesis. Major functions. Although much remains unknown about the Earth's core, we can ascertain that its behavior is crucial for sustaining life on our planet. Firstly, the movement of iron and nickel generates a magnetic field, which shields the Earth's layers from solar wind and UV radiation, thereby safeguarding life from harmful particles. Additionally, the core's emission of heat helps maintain the warmth of the Earth's surface. In fact, geothermal energy derived from the core's heat is sometimes utilized to heat homes, as seen in Iceland. Mysteries of the Earth's core. The Earth's layers lie just a few kilometers beneath us, yet our knowledge of the planet's interior is more limited compared to our understanding of the Moon. The deepest man-made borehole, the Kola Super Deep Borehole, reaches a mere 12.2 kilometers into the Earth, not even halfway through the lithosphere, the outermost layer. Seismic data constitutes the basis of our understanding of the Earth's inner and outer core. Another enigma pertains to the periodic reversals of the Earth's magnetic field. Although scientists have estimated the temperatures within, the extreme temperature and pressure prevent direct exploration of the core. Nonetheless, our current knowledge is a result of numerous innovative studies, and future research may uncover many more secrets. Study of Earth's layers. In the 1940s, scientists believed that the composition of the Earth's core held no secrets. They calculated the original distribution of minerals on Earth and concluded that the missing iron and nickel must be present in the core. However, gravity measurements conducted just 10 years later proved their assumption wrong. It turned out that the core must be denser and heavier than initially thought, although the specific elements within remain unknown. Nevertheless, this mystery may soon be unraveled. The researchers found that the molten core of the planet loses heat faster due to a certain mineral. The Earth was formed about 4.5 billion years ago and, as you know, began to slowly cool from the inside. Although the temperature of the Earth's surface and atmosphere rises and falls from millennium to millennium, its interior is steadily cooling. We are talking about the molten core of the planet, which, rotating, creates a magnetic field, a giant shield that protects life on Earth. Scientists also note that mantle convection, tectonic activity, and volcanism stabilize global temperatures on the planet, helping to maintain favorable conditions for life. Since the interior of the Earth is constantly cooling down, this will eventually cause the planet to turn into Mars or Mercury. All geological activity will stop on the Earth, and its core will harden forever. A new study shows that such an unattractive scenario could start much sooner than expected. The key to the puzzle turned out to be a mineral that is located between the iron-nickel core of the planet and the molten mantle. The boundary material is called bridgmanite, and its thermal conductivity affects how quickly heat seeps through the core into the Earth's mantle. A team of scientists led by ETH Zurich planetary scientist Motohiko Murakami recreated the necessary conditions in the laboratory to find out how well bridgmanite conducts heat. This experiment showed that the thermal conductivity of bridgmanite is about 1.5 times higher than previously thought, Murakami said. In other words, the flow of heat from the core to the mantle of the Earth turned out to be higher, which means that the rate at which the interior of the planet cools down is also higher. But that's not all. The scientists think the process could also be accelerating as bridgmanite transforms into another mineral, postperovskite. The latter has even greater thermal conductivity and increases the rate of cooling of the heart of the planet. So far, scientists cannot say how much faster the planet is cooling. For example, Mars cools much faster than the Earth because it is much smaller. But if there are other factors influencing the situation, the decay of radioactive elements can prolong the life of the planet by supporting volcanic activity. Such elements are present in the Earth's mantle, but the whole process is not yet well understood. The asteroid Psyche, potentially a naked iron core floating in space, presents an opportunity for gaining insights into the structure of the Earth's core. The upcoming Psyche mission in 2022 aims to provide answers and also facilitate comparisons with the iron cores of other rocky planets, shedding light on their common properties. Dear viewers of our channel, we are pleased to inform you that our team will keep a close eye on the latest discoveries and scientific advances in various fields. Our goal is to provide you with the most up-to-date information about the latest discoveries of scientists in the field of astronomy and many others. Whether it's the discovery of a new planet in the galaxy, the development of a revolutionary treatment for disease, or the creation of new materials with amazing properties, we'll try to keep up to date. To stay up to date with the latest news and discoveries, we encourage you to subscribe to our channel and like our posts. Your support will be an important motivation for us to continue to share exciting and educational stories about the latest scientific advances. Don't miss the opportunity to stay up to date and be the first to hear about exciting discoveries that are changing our understanding of the world. Subscribe to our channel to be among those who always stay ahead. Thank you for your support and interest in our work.